In making buying decisions, we usually select according to one condition only. For example, we select the lowest price, or perhaps the largest quantity. If we are flying, for instance, a non-stop flight costs more. But if we want the shortest time, for example a trip, at the lowest price, could that be a problem? Sometimes selecting alternatives that are hard to match is the problem. Setting up systems of equations that represent conflicting decision-making could go a long way in helping us solve quantitative problems. For example, using the first example from section 3.6 and building upon it, we see that Pat needs to rent a truck for a few hours to move. However, this time she will have two competing alternatives. The original one, where she would pay $40 per day and 50 cents per mile, and a new one where she would pay $35 per day, but the cost per mile increases to 54 cents per mile. Which one will it be? Lower daily rate or lower per mile rate? Obviously, the answer rests on the number of miles she plans to drive. Select lower per day alternative if the trip is short, or lower per mile alternative if the trip is long. In any case, we must find that miles numbers where the total cost of both alternatives are the same. We could solve the problem by trial and error, or we could write two linear equations that represent the conflicting alternatives and do it faster. Alternative 1, 50 cents per mile plus $40 per day. Cost equals 0.50 m plus 40, where m is miles. Alternative 2, 54 cents per mile plus $35 per day. Cost equals 0.54 m plus 35. Remember y equals y in section 5.2? In here, we make it cost equal cost. When costs are equal, what is the value of m? The two equations are placed against each other and solved by substitution. Subtract 0.54 m and 40 from both sides. Divide by negative 0.04. Negative divided by negative is positive. M equals 125 miles. At 125 miles driven, the costs are equal. This means drive less than 125 miles, select lower cost per day and higher per mile rate. Drive more than 125 miles, select higher per day rate and lower per mile rate. Another example. Isaac is 6 years older than Jose. Isaac was 3 times as old as Jose 2 years ago. How old are they now? Two alternatives, two equations. One today, the other one 2 years ago. Today, Isaac equals Jose plus 6. 2 years ago, Isaac minus 2 equals 3 times Jose minus 2. Solve equation for today and equation for 2 years ago as a system. I have decided to solve the second equation for Isaac. Add 2 to both sides. Eliminate parentheses by distribution. Combine negative 6 and 2. And then eliminate I by facing the equation against each other and solve for J, Jose. 3j minus 4 equals j plus 6. Subtract j and add 4 to both sides. Combine. Divide. Jose is 5. If today Jose equals 5, then Isaac equals 5 plus 6 equals 11. Another example. Two cars start a trip towards each other at the same time. One from Los Angeles, California to Miami, Florida. Another one from Miami to Los Angeles. The Miami car travels at an average speed of 48 miles per hour. and the Los Angeles car at an average speed of 52 miles per hour. If the distance between the two cities is 2,735 miles, how long will it take for the two cars to meet? Because distance is a function of speed and time, distance equals speed times time. And here times t is the same for both cars. Solve for t, where t equals distance over speed. If time Miami equals time Los Angeles, then distance Miami over speed Miami equals distance Los Angeles over speed Los Angeles. Because distance Los Angeles plus distance Miami equals 2,735, then solve for distance Miami and substitute distance Miami equals 2,735 minus distance Los Angeles in the previous equation. Solving equations as a system and substituting for speed LA equals 52 and speed Miami equals 48. Now cross multiply and solve for distance Los Angeles. Add 52 dLA to both sides. Divide both sides by 100. dLA equals 1,422.2. If distance LA equals 1,422.2 miles, then distance Miami equals 2,735 minus 1,422.2, or 1,312.8 miles. They would meet at 1,422.2 miles from Los Angeles, or 1,312.8 miles from Miami. To find time, divide distance by speed. Using LA distance and speed, the time was 1,422.2 divided by 52 miles per hour equals 27.35 hours. One more example. In a basketball game at school, 620 fans paid admission. If a student ticket was $3 and a general admission ticket $8, how many students attended if $2,405 were collected? Two equations must be extracted from the information. Students plus general admission equals 620, or S plus G equals 620. We call it equation 1. Number of students times $3 plus general admission times $8 equals $2,405, or 3S plus 8G equals 2,405. We'll call it equation number 2. Solve system by solving equation number 1 and equation number 2 algebraically. Line them up. Multiplying equation 1 by -3 will allow us to cancel S and wind up with 5G equals 545. Divide by 5. G equals 109 fans for general admission. To find the number of students, subtract 620 minus 109 and 511 students paid admission.